guys, it's me Mala from Step by Step Data Science, and in today's video we'll be talking about code analysis and using code analysis to improve retention rate. Long-term success for any business doesn't mean only getting someone to download the app or purchase the services once and done, right? But also like we need to get them and make them repeat visitors or repeat customers. So code analysis is where it's used in this place. So cohort analysis is a subset of behavior analytics that takes the data from given e-commerce platform or online games or any sources and look at the users as one unit by breaking them into a related group for analysis, and these related groups or cohort usually share common characteristic or experiences. And code analysis is also like highly used in tools to measure the user engagement over time, and it helps us to know whether user engagement is actually performing well or it just is there without any growth. And so today we will be going through code analysis. It is a retention rate, so we'll look at the business metric is retention rate using cohort analysis or medium size bikes and cycling transaction data. So generally there are three types of cohorts. It's time cohort, behavior cohort, and size cohort. So time cohorts by define it's like if some customers buy something or use some services, and we look at based on the time frame, so it's time cohort. And like for example, like someone bought some service on November but some other part on February, so we have a two time codes, one for November time codes and or February time codes. So that's the time code. Behavior code is also like based on their behavior or demographic content. So this is behavior cohorts. And size cohort refer to the sizes like of customer number of like how many orders or how many orders one person had does. Such kind of this like we can look this kind of matters in various kind of things, and based on that we can have different types of code. And in today's like we'll be performing cohort analysis based on time, and it is like highly used. And here like we divide customer into acquisition cohort depending on the month of their first purchase. And the cohort index will be used. This cohort index is highly a crucial part in cohort analysis. So the cohort index will yield then be assigned each of the customer purchase, which we will represent the number of months since the first transaction. And here like we will be dealing with mainly on monthly basis. For this two column we will use transaction date and customer ID to see our target retention rate analysis. So and we will be using data from customer transaction data. We have this data on Kaggle only, and the link for to download is in the description. So one objective of this session is like we will find the percentage of active customer compared to the total number of customer after each month. So it's customer segmentation and the retention, right? So let's jump to the code analysis basic. And for cohort retention rate analysis, everything the steps are same with any kind of matrices. So you have any matrices, that's the step are same. We just need to change few column and other kind of things. The first thing is like data loading and cleaning. This is always crucial part, right? So if you have given a time to our previous videos, then you are sure definitely know the importance of data cleaning and everything. Here also we will do some data cleaning like handling some missing value and such kind of things. And then on second we will like assign cohorts and calculate the month offsets. Like the so first step for this is like we'll like truncate data update into a needed one, because here we need month because we are going to look at the monthly basis. So from entire date transaction date we'll just truncate month and keep it as. And also like we'll group by object with like target column. So customer ID is our target column, and then we'll transfer a mean function to like assign the smallest transaction date in the month value to each customer. So out of this the result will be like we will have assigned the acquisition month cohort to each customers. And the next step followed by is like we'll calculate time offset by extracting integer value of the year, month, and date from a date time object, and we'll calculate the number of month between any transaction, like that is like first transaction for each customer. And we'll use like transaction month and cohort month. We use this. So with this, like we'll get difference between transaction and cohort month, and we'll have cohort index. So this is how we create a cohort index. So cohort index is nothing but it's a difference between transaction month and the cohort month, right? And the next step is like we'll create a group object by cohort month and cohort index, and count the number of each customer in each group by applying pandas and get function. And we will reset the index and create a pandas pivot. So pivot is highly crucial in data analysis process. So excel pivot, right, kind of this same concept. So we'll use pandas pivot and with like cohort month in the rows and code in the column and customer IDs count as a value, and this gives the table for calculating any kind of business matrices for. But our target here is like calculating retention rate, so we'll be using this. And till this, like you had in the cohort analysis, after this, based on that, you could have like retention rate analysis or any kind of other units. So cohort any units analysis, right? So that's the process. And then like yes, our target is like business matrix is retention rate. So we'll calculate the retention rate, see the retention rate, we'll visualize the, because everything definitely just looking at the number is hard, but if you can visualize then it's high. So here we'll use C1 heat map because heat map are highly used in cohort analysis, because here we can see number also and color encoded are also there, so that's highly used. And we will like interpret the retention rate. If you are familiar with the retention rate or not, but for a quick retention rate, just measure how many customers from each cohort have returned to the subsequent month, right? So retention rate is simply like if you buy some product today and you never come back, then the retention rate for that is zero, right? But if you buy someone today and after 2 months again you bought something from that one, so there is a retention, right? So a business can retain you because you came there and again after some interval you again came, so we have retained. So that's simply a retention rate. And so let's like interpreting the retention rate here, like I have shown how we can interpret. So we'll cover that next. And so overall, like after understanding and working with this notebook, like you will be able to understand what cohort and cohort analysis is. You will see how to handle missing value, how to extract day, month from date, assign cohort in transaction, calculate cohort table, and create retention rate, visualize it and interpret it, and also working with other business matrices. So let's jump. So like first and foremost is totally importing libraries, right? So we'll use pandas, cbun for visualization, matplotlib, numpy and datetime, and missingo. This missingo is highly used for like visualizing missing values and everything, and I find it's quite handy. And we'll use next is texttab. So these are simple, we don't need fancy libraries to download, these are the enough libraries. And then we load the data. So I have already kept name as xlx transaction xlx, so it is excel, so it is like we'll use pandas to read excel files. And then this is the snapshot of our data. So here we have a transaction date, so we'll just take out this month based on this month transaction, and another hour is like customer ID, right? This customer ID based on how which customer return on which, and so kind of, because we are looking for retention rate. So now we'll see how many missing values are there. So like using this missingo library msno, we have taken as msno, right? For missingo library we'll see which column has missing data. So here we have 20,000, 20,000, 20, but here online orders and this product class, product line, and every other have like some missing values, so we need to treat that. And for that, then we can like this is one way of like visualizing missing data. And other like previous way is like using isnull and finding its sum, so how many missing value are there, and then replacing that missing value is nas. And with nas we'll fill all nas value with the mean value of that column. So this is called mean imputation, which is highly used if you do not have like much complicacy. But before inputting anything, you should have some knowledge about what imputation is, other things. And soon on our next video we'll bring handling missing values and other kinds of things. And so like here so for now we'll like mean imputation, and then we'll count the number of data set to verify it, right? So also like if those numbers are not numerical but they are object type, then also we need to fill value, and we cannot fill with numerical. So for that what we'll do is like we'll use most frequent value, we'll input with most frequent value all object, and here we have 0 missing values. And let's see again, and if you again see, we all data are now complete. So we have no any missing values and everything. This is simply like how many columns we have, and whether transaction is in date time format or not, because if it's not in date time format we cannot calculate, we can extract month and so kind of things. This is what we done here. And so now we have already like we clean the data, we have understanding of how data frame looks like and everything. So now we'll jump to assigning code and calculate the monthly offset, right? So at first we'll use get month function, and from that time we'll extract year, month, and one day of the month, because like we are like focusing on the extracting month. So on day we'll keep just one. So having one every month or every year, every month will have only one at the end of the day, and they will not have like second day or third day or such kind of, they will have one. And then we'll create a transaction date column based on the month and store in transaction month. So extract the month and we'll apply get month and we'll in the transaction month, and we'll group by customer ID and select invoice month value. So we'll like group by customer ID and transaction month, and we'll assign a minimum invoice month value to the data set using a main for this cohort month. So this is how we get cohort month. So see here, every year or every date have only one day, so we have a different month, right? But repeating day. Now we'll calculate time offset in month as a cohort index. So for calculating time offset for in transaction, we'll first create 6 variable that capture the integer value of year, month, and day for transaction and cohort date using a get date in function. So using get date in function, df column, from df the column year we'll like extract year, month, day, and then and again we'll get the integers for date path from invoice date column. So this is transaction month, right? So transaction df, and we'll get in transaction month and year, and we'll get integer for the date part from the cohort date column. This is a cohort. Now we will be calculating the difference between invoice date and cohort date in other months separately, and then we'll calculate total month difference between these two, and this will be our month offset, that is cohort index. So as previous, cohort index is nothing but the difference between simple difference between variable, because I already told, because it's difference between transaction month and cohort month, right? So this is what we do here, and it's totally crucial and crucial part of the cohort analysis. And so here like we'll get the year difference and the month difference, and we'll extract the difference in month from all previous values, and we'll be at +1 at the end of the first month, because if like in programming there's a meme saying like other count from 1 and programmers count from 0. So similarly, if we do not add anything, then it will like make January as 0, February as 1. But instead that's not in real life we do. In real life we do 1 is January, 2 is February, such kind of things. So year difference by 12, we have 12 month, and the month difference +1. So right, and this is cohort index. This gives the cohort index, and cohort index is simply the month. And after that, like we will first create group object, cohort month, and cohort index. Now here we do some pivoting, and then we call this object like customer ID column and calculate the average, because we need to calculate the mean values, and then we store as cohort data, and then we will reset the index before calling the pivot function, and we'll create a pivot table by passing cohort month to index parameter, cohort index to column parameter and customer ID to the value parameter, and we'll round up it to 1 digit so that we can get a good result. So here, now we'll group by growth month and cohort index, and then we'll count the number of unique customer ID falling in each group using an unique of a panda series, and then we'll reset indexes, and we'll assign the cohort name. So like this is so for index will cohort month, because for column cohort index and value customer ID, and this is what we get, and we'll round up to 1 digit, and this is the data, and this is the table of cohort analysis. Now after this one, whatever we do, it's all related to business. Till this one we have cohort analysis, some technical, but after this it's all related to business matters, whether it's a retention rate or any kind of business matters that you are focusing on. So here like we'll calculate the retention rate, and since like a first core, like we'll first select the column and store in the cohort sizes at the size of cohort, that is number of active customer in first day, and then we'll store the first column as cohort sizes, that is total number of customer in that cohort, right? So cohort size is cohort count alloc, and this is the way to extract first column from the data set, and then we'll divide the value in other column with cohort sizes in order to like calculate the retention rate, that is the number of customer in each cohort index. So using the divide cohort sizes and x is 0, so x is 0 means like we are not creating a copy of the data and do some like mathematical things, but instead we are doing on the original data set only. So it will change the value on the original data only, and after that we will have cohort matrices, because this will have the cohort matrix side, and in cohort matrix on the x and the y, on the y we will have cohort months, and on x we have cohort index. And cohort index is simply that January February, because we are looking at the month basis. So this retention rate data frame like represent the customer return across each cohort, and simply we read this this is like cohorts, and this is the month since current cohort. So right, and okay, so like how do you like before analyzing, let's like visualize the retention rate. So we'll visualize like we don't need like this one of the day, we just need year month. So we'll just like strf time, so y and month is like year and month, we don't need other days, so we just have this one. And then we will like plt and figure size is 1610, and we'll add title retention rate in percentage monthly cohort, and we'll like using the c1 you will create a heat map, right? Using heat map on the y level we have cohort month, and on the x level we have cohort index. Now how to interpret? So this is the retention rate for the bikes and cycling transaction data. Here like let's see here this 48% is right. So this 48% for 2017-07 month says that 48 percentage of the customers, yes right, 48 percent of the customer will return after first, second, third, fourth, fifth month. So for seventh month is January, February, March, April, May, June, July. Those customer who sign up in July 2017 were returned January, February, March, April, May, were returned on the May, January, February, March, April, yeah, return on the May. So this is what it says. So okay, this simply say that this simply says that the customers like here color wise, so the darker the higher the number, right? So on the this column we have 100%. This 100% means that these are the, because all the customer of this cohort sign up in the first month of that, and then how they return after 136% of the customer who signed up in 2007 were active like 2 months later. And similarly, so here like we go 46%, right? So 2017-04, those customer who signed up on April 2017 were active after the active 5 more active after 4 months later. So this is how we interpret. So like, yeah, here like we have 12 cohort for each month and 12 cohort indices. So this is how we interpret. So here I have clearly written that. So if we see on 2017-07 cohort month, right, 2017-07 cohort month, it is 48%, which means that 48% of the cohort that signed up in July 2017 were active 5 months later. So this is how they active after 5 months only. So so this is how our code analysis for retention rate is done. And thus like we complete our code analysis, like where you learned about basic type of code analysis, performing time cohort, working with pandas pivot, creating retention table along with visualizing it, right? So there are other matrices you can even try. So how do you like, if you get a new matrix, how do you like simply change it and working it? So here like we use customer id. Like instead of customer id, if you want to look for like listing price, you just simply swipe listing price here, and everything same, and you'll get the listing price in percentage or listing price in any other things on monthly code, how listing price will change or such kind of thing. Any kind of matrices you focus, just change on that. So extra reading. And so if you want to expand your knowledge like more from just staying in home, then definitely check out our step by step data science channel. And thank you very much for being up to this, and I really appreciate your time by making after this. So take care, and if you have any comments or anything, please write in the comment and we'll solve it out. Thank you and have a good day.